So we'll spend some time understanding what inverse functions are and then what inverse trig functions are. But first, let's look at the essential idea, right? If I know I have 30 degrees is my angle, and I want to find what is sine of that, 1/2. This is what the trig ratios or the trig functions give us, right? But sometimes we have the opposite problem. I know that the sine ratio of some angle is 1/2, and I want to know what is the angle. So my problem is the opposite now. I know the ratio and I want to find the angle. Okay, so if I could make another function which could take this and give me 30 degrees as the answer, then I can now go in the other direction. That's the idea of the inverse function. So this will be inverse of sine. We'll learn what that is, but it's just telling us, oh, if this was the y for or the output for the sine, then this was the angle, right? So in terms of the triangles, I'm trying to figure out what this angle is, right? And this is given to me like that. I know the opposite and I know the hypotenuse, right? So I know that sine theta is 2/4. So what is theta? The theta is 30 degrees. But how did you know that? So you kind of going back to the table, right? And looking it up in the other direction. Instead of starting from the angle and looking at the ratio, you're looking at the ratio and then looking at the angle. Right? In general, right? This could also be 150 degrees, right? If it's not this triangle, just looking at the ratio, right? Because sine of 150 is also 1/2. So what is happening? From half, I can get 30 degrees. I can also get 150 degrees. I could also get 390 degrees, right? How many different angles can I get? Infinity, endless, right? So can this be a function? Can this be a function? For one input, I am getting so many outputs. Here, if we're saying we want to have some function which will take the ratio and give me the angle, I can get so many angles for one input ratio, right? Then will this be a function? So it will not be a function. And let's see visually what that means, right? So for example, so this is sine, right? And then this takes angle as the input and ratio as the output, right? So if we're trying to make the inverse function, there the input will be the ratio. If I got half, right, I got basically the graph will become like this, right? So now you can see for half I'm getting 30 degrees, 150, 390. See what's happening? I'm trying to do the inverse, right? So now my input became the ratio and output became the angle. And for one ratio, I'm getting so many angles, right? So that's not a function. So that is a problem. The problem is that if I go in the other direction for sine, then I run into this problem that it's not a function anymore. Same thing you will run into with cosine, tangent, right? All of those are periodic. So you'll have some problem like that. If we go back to the sine function, because I can draw a horizontal line here and it fails, right? There won't be an inverse function for the whole sine function, right? So what is the problem? The problem is it's going up and then also coming down. So it can come back to the same spot. Similarly here, it's going down and then also coming back up. So again, you can have multiple intersections. So what we do is we do want to know an inverse for sine because at least, you know, we want to figure out the angles from ratios when we need to. We won't use the whole sine function. will only chop off a portion of it. This is negative pi over 2, and that is pi over 2. If I only keep this much of the sine function, now can it have an inverse? This is called restricting the domain. If we restrict the domain of the sine function from negative pi over 2 to pi over 2, then I can have an inverse, because now there is no problem. There is no repeating situation. Horizontal line test passes. So now I can have an inverse, and this is called, either we write it like this, sine inverse x, or we call it arc sine x. The inverse, this is just sine. This is still sine, right? What's the domain for this sine x? Restricted domain. So domain range restricted. So this is negative pi over 2 to pi over 2. And what is the range? Negative 1 to 1. Okay. So when we take the inverse, you have to remember this. This is very important. For any function, if you have an inverse function, then their domain and range switch, right? Because the output becomes the input and input becomes the output. Because arc sine x will take this as input and will give that as the output. So the domain and range will switch. Because now you're giving the ratio and it will give you back the angle, right? So arc sine x or sine inverse x will always give you an answer between negative pi over 2 to pi over 2. And if you're trying to find all possible answers, then from there you can figure out, oh, you can add 2 pi, you can add 4 pi, you know, all those things you can do. But arc sine x will give you an answer in the negative pi over 2 to pi over 2. So essentially what you need is you have to see a portion where it either keeps going up or it keeps coming down, but it should not go up and come back down, because then the horizontal line test will fail. Let's look at how we can restrict the domains for the other things, right? So for cosine x, if we have to find the inverse, and then we have to stop because it started at the highest, came to the lowest. If I go either side, then it is going to fail the horizontal line test, right? So this is 0, this is pi over 2, and this is pi. So cosine will go, I mean, we can take any interval, but I'm telling you the one that people have agreed to use as the main interval or the restricted domain, right? So for cosine x, our restricted domain is 0 to pi. This is for making the inverse, right? So if you want to go from ratio and figure out the angle, then we will have to do the arc cosine or cosine inverse. The domain for this will become negative 1 to 1, and the range will become 0 to pi. So when you're taking cosine inverse, your answer will be between 0 and pi. And from that, you can find the other possible angles. For tan x, what should be the restricted domain? See, the whole period is pi. And if I go anywhere else, then the values will repeat, right? Because it starts again here. So if I cross it, then I will have a failure of the horizontal line test, right? So it goes from negative infinity here to positive infinity. So tan x in the restricted domain will go from negative pi over 2 to pi over 2, and the range will be negative infinity to infinity. So arctan will go from negative infinity to infinity as the domain, and then the range will be. So cotangent will work like that. Cosecant, this is sine, right? Cosecant went like that. We have to take a portion where it doesn't cross, right? So if I do here a horizontal line, it will cross. I have to cut it off here. right? And similarly, I have to cut it off here. So only this will remain. Then it won't be a problem. There is no horizontal line failing, right? Which comes to negative pi over 2 to pi over 2, which was same as the sine, which was also negative pi over 2. And if we take secant, so secant is 1 over cosine. So again, just like cosine, we could take this portion and that portion, and then there is no problem, right? If we include these, then there will be a failure. So this can also go from 0 to pi. So basically, the sine and cosecant are the same, cosine and secant are the same, and tan and cotangent are the same. So you try to start from 0, either you go 0 to pi or you go negative pi over 2 to pi over 2. So these are the restricted domains. We take a portion of the sine, cosine, tangent graphs or functions in a limited domain so that we can find the inverse. So the horizontal line test will not fail. Okay, and then using that, we will be able to find the angle for the ratio, the inverse of the function.